This is the second in a series of videos in which I'm looking at this machine. It's an IBM display writer built back in the 1980s. It's actually a glorified word processor, so it's kind of like a dedicated PC that is only designed to run word processing software. And in the first video I took the case off, we had a look inside, and what I've done since then is remove the power supply, clean it internally, and I've tested that all the supply rails are within spec, and that's working fine. I haven't cleaned the rest of it yet, so I've decided what I'm going to do is power it up. I've checked for shorts on the boards, so all the rails, I've made sure there are no short circuits on there. And what we'll do now is switch this on. I've got the keyboard connected, so we've got a monster keyboard over here. It's a really big heavy keyboard, and I've got the monitor connected as well. So I'll point the camera at the monitor and I'll power up the machine, and we'll see if we get anything appearing on the screen. I don't have a high degree of confidence that we'll see anything. These machines can take quite a lot of work to get up and running, but we'll see if we get anything at all. So I'll power it up. It's drawing about 0.3 amps from the 240 volt supply. No noises. The fan isn't running on the supply. I think it's temperature controlled, so I don't think it's going to run until it gets hot. And we do actually have something on the display. Nothing much. It looks like we have no vertical drive. So we're also getting horizontal. We are getting some data by the look of it coming through from the machine as well. So this looks like it's just collapsed display. What I'll do is I'll try pressing the enter key on the keyboard and see if we get any activity on the screen. If we're getting activity from the machine, we should see something change, and maybe something will move across the screen. If this is just garbage that's come up because the machine's not running, then chances are nothing will change. So I'll try pressing the key, and we are indeed getting something appearing on the display. Okay, it doesn't seem to be doing much, but then it's most likely trying to boot from the floppy drive at this point, so it could just be an error message on the screen. So the next thing to investigate is why we're not getting any vertical drive. So what I'll do is we'll go back, I'll get the scope hooked up, and we'll look at the pinout of the video connector on the machine and see if there's any video drive signal being produced at all. Okay, I've got the scope hooked up. It's currently connected to pin 13 of the display output socket, and that in theory should be our horizontal drive. So it should be quite a high frequency signal on there. I'll power it up and we'll see if anything appears. It might take a few seconds. It's obviously got to boot the machine before the display will come up, and there is indeed a signal, which we kind of expected because we were getting scanning on the screen of the scope. So I'll do a single shot capture so we can get an idea of the frequency, and it's saying 15 kilohertz, which is kind of what we'd expect for this type of monitor. So I'll move the probe of the scope onto pin 12, and that should be our vertical drive, be a lower frequency. Okay, so we'll do a new refresh and see what the frequency on this pin is, and that's 128 Hertz, and again that is what we would expect to see for this type of display. So it does appear that the signals are stable and correct. So I'll plug the monitor back in, just confirm that we're not getting any display and that it wasn't just a poor connection. Okay, I've got the monitor plugged back in, and we'll try powering up the machine again and see if we get anything different on the display. So it's still showing the same thing. I'll try pressing the key again, We are getting something appearing on the screen, but still no vertical deflection. So I'll pop the cover off the display, we'll have a look inside and see if we can figure out what's going on. I've removed the outer case from the monitor and I've pulled the board out. Luckily this is quite a nice arrangement that you can leave it connected and just rest it on the bench. The other thing I need to do is extend the ground wire. It's too short to have the board on the bench, but all the rest of the connections are long enough so I can arrange it like this. Usual thing, all the foam has degraded in this, so it just fell out when I took the outer case off. I'll replace that before I put it all back together again. So the first thing I need to do is see if the sync drive signals are getting to the board. It's possible we've got a problem in the cable, so I'll check those first. I'll power the machine back up. So what we'll do now is check to make sure we're getting the correct sync pulses going to the board. So 70 Hz. The frequency will have changed now, of course. I've got it plugged in, so we're seeing the frequency that it should be refreshing the screen at. So we should be getting one at around 60 Hz or so, one at around 15 kHz. Okay, so that's 70 Hz or 69.4, and we'll check the other one, and that's 15.6 kHz. So they both look correct, they're the correct amplitude, and so we know that these sync pulses are getting to the board. I already have a fair suspicion as to what's causing the problem on this board, and anyone that's familiar with repairing old black and white TVs and monitors will probably also have spotted it, and that's this device down here. It's a TDA 1170S, and it's kind of an integrated vertical drive system for black and white monitors, and they are notorious for failing. I don't know if it is that yet, so we'll check it. Because I don't want to be reaching past this cable, which is the EHT cable, what I'm going to do is flip the board up on end so I can access the IC from the underside of the board, and that way I wanted to keep reaching past this to check the IC. So I'll just get that moved. Okay, so I've got the board turned over so I can access the underside of it more easily without having to get too close to the EHT connection. Now, looking at this particular type of device, I don't have the schematic for this particular monitor, but quite often what you'll find with simple devices like this is the designers take the obvious and most logical step when they're designing these, and they use the reference designs, or at least they stick very closely to the reference designs given in the spec sheet by the manufacturer of the device. There's no reason not to. They're not going to try and make life more difficult for themselves than they need to. So if I don't have the schematic, quite often what I will do is print off the reference design for the particular device I'm trying to fault find with, and that's what I've done here. So this is a typical reference design for the TDA 1170, and looking at the board, it does seem to match fairly closely. At least certain aspects of this seem to match fairly closely. So we'll use this as the starting point, and depending on what we find, we might have to add a few things to this schematic to make it match, but we'll do the simple things first. Now the first thing I have to do is determine where the ground is on this system. I don't know if the ground reference on the device, get the spec sheet again, so I don't know if the ground here is referenced to chassis ground, so that's what we'll measure first. So I'll turn the unit back on. Let's lower the camera a bit so you can see the entire board. Okay, so what I'll do now is measure the ground pin potential to see if it's connected to chassis ground. So I'll power up the board. I'll put the scope on that ground pin. and the scope's on 5 volts per division, so we're seeing about -8, -9 volts there. So we just need to take that into account when we're taking measurements for the rest of the pins. I could move the ground clip, I don't want to do that. I don't want to attach mains ground to that point, because I might get a ground loop and blow something up, so we'll just need to take that into account when we're looking at the rest of the measurements. So the next thing to look at is the supply voltage. That's pin 2, and if we look at the reference design, we'll see that in the reference design it is connected directly to the supply. So you won't be able to see this very clearly, but pin 2 is down here, and if I follow it back, it goes through to a capacitor, so I'll scope that. And as you can see on the scope, we're getting exactly the same voltage there that I was getting on the ground pins. In other words, there is no supply voltage going to this. This is ground. So I follow it back through, and it goes back to this point, and 11 is a low value resistor. On the other side of that resistor I'm getting 12 volts, and actually marked on the board here it's saying plus 11.8 volts. There's a small legend here that's saying 11.8, which I am getting, but there's nothing on the other side of that resistor. So what I'm going to do is just, so what we're here, there's a resistor in series with the supply, but we're getting nothing here. So I'm going to turn the board off and just check to see if we're getting a short to ground from pin 2. Okay, so I'll put the meter here, hopefully you can see it. Not sure if you can see that or not. I can't really see much through the camera, but hopefully you can see the meter. And I'm going to do a measurement between pin 2 on the IC and ground. That's its own ground, not chassis ground. Okay, and there is a dead short between those two. Okay, so there's a dead short on there, so if I follow it back, then we have a capacitor. So it looks like it is very close to the reference design. So there is a capacitor in this position, so I'm going to measure across that. And we are indeed getting a dead short across that capacitor. So that's either there's a short inside the IC to ground, or the capacitor itself is shorted. So the easiest route here is I'll pop this capacitor out and see if the capacitor itself is shorted. If not, then it will be the IC itself, but the easiest thing to try is the capacitor. So I'll get that taken out and we'll see what happens. Okay, so I've popped the capacitor out. I'm just going to measure across it and see if it is indeed short circuit, which it is. It's showing it as dead short. Okay, and then we'll just measure from pin 2 on the device to ground. That's its own ground. And that's now showing pretty much as open circuit, so the short has gone. I've got a feeling that this low value resistor is open circuit as well. Most likely it burnt out when the capacitor went short. It's reading open circuit as well. I've had a quick look and I can't actually read the value on it. It doesn't look too badly burnt up, but I think it's just overheated and burnt the colours off. So I don't know what value it should be, but I'm going to put a 0.1 ohm resistor in there. It's only a noise suppression resistor, so it's not a critical value. I'll find a replacement for this. It's 2200 microfarads at 16 volts. It looks fine, it's not bulged or anything, it's just dead short, so I'll get this changed. It is subject to quite a lot of ripple current, so that's probably what's killed it. And I'll get this replaced, find a replacement for the resistor, and then get back on camera and we'll see if we've made any progress. Okay, I've replaced the capacitor. I've put a Rubicon equivalent in, so that's 2200 microfarads, actually 25 volts, so it's a slightly higher rated one, also much better quality. I've replaced the resistor. I've actually put an inductor in place of this. Like I said, it's there to filter out noise and stop the switching noise getting back into the rest of the board, so an inductor will work a little bit better there. And I've just put a low value in, so it won't interfere with the voltage supply to the device, but it should keep the noise level down. And what I'll do now is try powering it up. Before I do that, I'll move the camera so you can see the screen and see if it's made any difference. Okay, I'll power it up and see what happens. Take a few seconds to warm up, of course, and we'll see if we've got a line or anything different. Okay, I can't see it that clearly, but we are now getting text on the screen. I'll try pressing a key, and it's just coming up with a value of 04, which I'm assuming is an error code, possibly that it can't find the floppy drive, but I'll look at the manual for that. The next step is I'll get the monitor reassembled and see if it still works after that. I've reassembled the monitor, so I'll dim the lights and try and power it back up. And we'll just wait and see if anything appears on the screen again. Okay, we are now getting text. Needs focusing a little bit, or the screen's really dirty, one of the two. So I'll try and press a key, and it's just coming up with a value of 04 each time, which as I say, I'm assuming that's some sort of error code. So what it's saying on the screen is 801, that might be referring to the floppy disk drive, and a value of 04. So I'll try and see if I can find out what that means in the manual, and then in the next video we'll continue investigating this to see if we can figure out what's going on and why we're seeing this message. If you do have one of these and you're familiar with this and you know what's causing it, then please leave a comment.